So others who have not joined the session, this peer deck, please go to joinpd.com and use this code that you can see on the right side of the screen on the top.
Hello, ma'am.
Yes, Naveen.
Ma'am, I need some help. I have some problem in the statements. Suppose a situation is given to us. Say, some
Okay.
customers are entering a shop.
Okay.
Hmm. So, how do we know that it follows a Poisson distribution? It follows Bernoulli. Bernoulli is clear. Okay, we have either it would be true or it would be false. Right? There would be
Mm.
two situations. Either the event, suppose like tossing a coin, it's Bernoulli,
Mm.
and customers entering a shop, and how to relate all the
Le-
situations to which distribution do they follow.
like, okay, if for you Bernoulli is clear, binomial is clear, geometric should also be clear. Then, no, geometric should also be clear, right?
Ma'am, I have some now. If you could spend 5 10 minutes to just to explain that, this
I
should be
can
kept in,
do it. I
suppose
can
is
do it at the end. First, let first let's do solve with this, and then we'll do your problem.
okay.
Okay. Yeah. All right then. Um, okay. So here is a question. It says, suppose that number of customers reaching a particular shop in an 1 hour time period follows the Poisson distribution with an unknown parameter lambda. Okay. Now, from the previous record, uh, now lambda here is a parameter, right? Now, from the previous record, you have seen that the probability that your lambda takes the value 5 is 0.4, and the probability that your lambda takes the value 7 is 0.6. Now let's say if in a particular 1 hour time period interval, some 9 customers are reaching the shop, then what is the posterior mode of lambda? You have to find the posterior mode. So you must have seen in the first lecture of the week 10 what is posterior mode. So just try to find it out. Is it done? I can see like only 7 responses here. Or do you need more time?
Yes, ma'am. Just for a 5 minute, 2 minutes.
Okay, let's take 2 more minutes. Okay, let's see the solution part now. Okay. How is it coming like below 2? Like there are only two options, no? 5 and 7. All right. So, what are we going to do here? Anyone? What exactly, like when we are saying find the posterior mode of lambda, uh, what are we trying to do here?
Multiply the likelihood with the prior.
No, like posterior mode of lambda. So there are two possibilities here, right?
Yes, 5 and
5
7.
and 7. Now we have to check which probability is maximum,
Yes.
right? So yeah, the probabilities for lambda and lambda equal 5 and lambda equal 7 is already given to you. So what was that? It was probability lambda equal 5 equal zero point 0.4 and probability lambda equal 7 is zero point 0.6. Now you want to check, given that the 9 customers have entered the shop in that 1 hour time interval, uh, given the 9 customers have entered the shop, so in that case, which probability will be maximum? Probability lambda equal 5 given x equal 9 is maximum, or probability that lambda equals 7 given x equal 9 is maximum. So we can use this Bayes rule. So what we can do here, like probability x equal 9 given lambda equal 5 into lambda equal 5 divided by probability x equal 9, right? So this is quite simple. So this you have already done this exercise in like the first part, and here in this case you just have the Poisson distribution.
Excuse me, ma'am.
Yes.
Is it wrong to say it depends on the value of lambda? The value of the posterior move will be 7.
uh, what depends on the value of lambda?
The higher the value of lambda,
Higher the value
that will be the
of
move lambda.
uh, no, why do you say that?
The we have two probabilities. Probability of lambda is equal to 5
No,
is 0.4.
we are saying we have to the our parameter lambda is taking two values, can take two values 5 and 7, and
Yeah.
with what probability your lambda is taking the value 5 is 0.4, probability with which your lambda is taking the value 7 is 0.6, right? Now
Yeah.
what if you look at the question here? See, the question here says if in a particular 1 hour time period interval, some 9 customers reach the shop. Okay, the double the, then find the posterior mode of lambda. So this is the information that is given to you. Like 9 customers, you know that 9 customers have entered the shop. Then in that case, given the 9 customers have entered the shop, what is the probability that your lambda will be 5, right? then
Okay.
then you use the base rule. So base, if you use the base rule, it becomes probability x equal 9 given lambda equal 5 into probability lambda equal 5 divided by probability x equal 9, right? Probability lambda equal 5 is already given to you, and probability x equal 9 given lambda equal 5. So you know this x follows this Poisson distribution here. It is given to you in the problem that x follows, just look over here. So it says suppose that the number of customers entering a particular shop in a 1 hour time period interval follows the Poisson distribution with unknown parameter lambda. Okay, so it is given to you that x follows this Poisson distribution. I mean, not explicitly it is said that it is x, but we are assuming that your random variable is x. Now so given probability x equal 9 given lambda equal 5, right? So what is the probability, like what is probability x equal k if x follows the Poisson distribution? It is e to the
Lambda
power,
per k e power minus lambda by k factorial.
yes, right? So we just we know what our lambda is. Lambda is equal 5. We know our x. We just substitute everything and we get our value. Same thing we do it for repeat it for probability lambda equals 7 given x equal 9. So once you do it, so here like we have not calculated this probability x equal 9. You can calculate it whatever you find it easier. So what we have done here is uh, we have just taken the division of both the terms. So if you do that, you see that this turns out to be greater than 1. This ratio, probability lambda equals 7 given x equal 9 divided by probability lambda equals 5 given x equal 9, this ratio turns out to be greater than 1. So what does it mean? It means that this probability lambda equals 7 given x equal 9 is greater than probability lambda equal 5 given x equal 9, right? So once we know this
I have a
probability is,
question.
yeah,
What would we do if the value of lambda gets interchanged?
yeah, that's not a problem.
It depends on the value of lambda, no? That is what I'm asking.
But why will it get interchanged? I mean, you're finding lambda equals 7 given x equal 9. You're finding lambda
No,
equal
no.
5 given x equal 9.
Lambda is equal to 7 is 0.4 and lambda equal to 5 is 0.6. This is what I'm saying.
Oh, that is what you're saying.
Yes. In that case, what would be
And
the
not necessary that your answer will change. It may be maybe for this particular term, for this particular question, it's coming out to be like that, but maybe it can be something else. It is quite
Okay.
possible because you have other terms too, right? You just
So
don't have
is it
probability
possible
lambda.
if the value of lambda is 5 given lambda is equal to 5 is 0.6
Hmm.
and lambda is equal to 7 is 0.4. Fine.
Hmm. Yeah.
Then the posterior mode would be 7 or 5. This
Yeah.
is what I'm asking.
Then calculate. No. What will happen? Like now, what you just said. According to that, in the numerator, you just put zero point 0.4. So let me
Correct, correct,
calculate.
correct,
So
correct.
you will have e to the power minus 7 into 7 to the power 9 into zero point 0.4.
Yes,
So you're getting
less than 1.
so that's what I said. No, it is just one example.
Okay, okay.
Yeah,
If both the
I mean,
probabilities are same,
even
then we'll call it bimodal.
yes, you can call it bimodal.
If both the
Hmm.
probabilities are same.
Yes,
Okay.
if it turns out to be same, yeah, you can call it bimodal. So this whole process is clear. How to find the posterior mode? Okay, let's move to the next problem. All right. So here it says. The call duration of daily stand up meetings of employees of a certain company follows the exponential distribution with an unknown parameter lambda. Okay. Now, duration of last 12 meetings are given to you. Find the Bayesian estimate or the posterior mean of lambda using the prior distribution exponential 1 by 20 for lambda. So, first of all, what is your prior distribution given here? What is a parameter? First of all, what is a parameter?
Lambda.
Lambda. What is the
Lambda
prior distribution of lambda?
exponential.
Exponential, right?
Yes.
And you have to find what you have to find the Bayesian estimate, that is the posterior mean of lambda. Okay. Uh, Only 7 responses so far. Anybody else want to answer? Or you need more time? Do you need more time?
No, ma'am.
No, okay. Should we move with the solution then?
Yes, ma'am.
Okay. Okay. 8 responses. Fine. So, what is the question says here? It is given to you that the call duration of daily stand-up meetings of employees follows the exponential distribution, where the unknown parameter is lambda. Okay, so you have a situation given, and you are defining. You're saying that uh, it follows the exponential distribution. So let's see, you have a random variable x that denotes the call duration of daily standard meetings, and this x follows the exponential lambda. Okay, so lambda here is an unknown quantity. Okay, so this is a parameter. Now it is also given to you that from the last 12 meetings, what are the records? Okay, so it is given to be 35, 30, 25, 15, 25, 20, 20, 28, 34, 30, 15, 23. So these are the records from the last 12 meetings. So these are the timings for which the daily stand up happened. Now, given this information, you have to find the Bayesian estimate of lambda. So Bayesian estimate means you have to find here. In this case, it is posterior mean. So you have to find the posterior mean of lambda, and you have to use the distribution that the lambda follows is exponential 1 by 20. So prior, we know the parameter is lambda. The prior distribution that your lambda follows is exponential 1 by 20. So how do you find the Bayesian? How do you find so before finding the posterior mean, what should we try to find before finding the posterior mean?
Likelihood, ma'am. Should we find the likelihood?
Okay, yes, likelihood we should find, and what
And
else
it
we
is
should find?
proportional to likelihood times the prior.
So okay,
From that
so
we
for finding the
Posterior
posterior
density
mean,
is required.
yes, posterior density, you have to find what is the posterior distribution, and only if you find the posterior distribution you can find the posterior mean. And how do you find now the posterior? So posterior, prior times likelihood. So prior is given, likelihood is given to you here, so you
yeah.
just have to find the posterior.
Likelihood is like lambda into e power minus 35 lambda, then lambda into e power minus 30
Yes, yes,
lambda,
yes,
and then
right.
we add it like minus
Hmm.
35
Yes,
plus minus
yes,
common 35 plus 30 25 and all these sum
yes,
into prior.
yes. Okay, let's go back to the solution now. So here you see this weird sign here. So it's lambda. This is a lambda, basically capital lambda. So let capital lambda be the prior distribution of this lambda. Okay. Now it is given to us that it follows your prior distribution of this lambda is exponential 1 by 20. So exponential 1 by 20 means what? That in this case, it is 1 by 20. Parameter lambda is 1 by 20. So it is going to be 1 by 20 e to the power minus lambda by 20, right? This part is clear. Why f lambda of lambda is 1 by 20 e to the power minus lambda by 20?
Yes, ma'am.
Because it
Okay.
follows exponential 1 by 20 and yeah.
Yes, yes. Okay, all right. So now we have to find the posterior distribution. So posterior distribution is proportional to prior times the likelihood. Okay. So likelihood we already saw before. Sorry, prior we already saw before. Now the likelihood we know it follows the exponential distribution, and you have 12 different samples given to you. So you just have to do lambda to the power n e to the minus lambda x, right? So if you do that, if you multiply each of these uh, basically in this case here in place of n you have 12. Okay, so you just multiply everything, and if you do it you will get this sum term, right? E to minus lambda summation of xi's. Now I can combine these both, this prior and likelihood, and I can write lambda to the power n e to the power minus lambda, this sum over xi plus 1 by 20. And this 1 by 20 constant term, we can just ignore it because it is not going to come in our distribution part. It won't matter. So we can just avoid the constant part. So if you look at this posterior density, that is lambda to the power n e to the minus lambda sum over xi plus 1 by 20. So how does it look like? I mean, what kind of distribution does it follow? So gamma, right? So if you look at the gamma distribution, it's something like e to the minus lambda x to the power alpha e to the minus lambda e to the minus beta x, right? X to the power alpha e to the power minus beta
X to the
x.
power alpha minus 1.
Okay, yes, sorry. X to the power alpha minus 1 e to the power minus beta x, right? So from there, if you compare this, you will get this posterior density to be like this gamma. So n here in this case for lambda you have n, so it will become n plus 1, and you have this second term, that the sum of xi plus 1 by 20. Now we know that n is 12, n is given to be 12 in our case. So we'll just do so in case of gamma distribution, what is the mean?
Alpha by beta.
Alpha by beta.
Alpha by beta.
Yes. So we can just do alpha by beta and just substitute the values, and we'll get the posterior mean to be 0.04. Any doubt over here?
No.
Only one doubt: how do we get to know that this is gamma, this is beta?
Yeah, so all the distributions will be given to you in the exam, and uh, for like I would say the more you will solve the problems, you will see more such kind, and it will automatically get into your mind. But yeah, for the exam purpose or for your assignments or when you're solving some problem on your own, just it is always available to you, so you can just refer it, and in the exam the reference sheet will be provided. So
Can I ask a question?
yes.
We took the PDF of gamma to be x to
X to the
power
power alpha minus 1
minus
e to
1,
the power minus beta x.
but the formula sheet says in addition there's something beta to power.
So that is a constant term, so that's why we are ignoring it there. So that is a gamma function. So gamma function, I'm sure you have not seen before, so it's okay, do not worry about that. You just have to remember that your if x is a gamma, x follows the gamma distribution with the parameter alpha and beta, then the its PDF follows x to the power alpha minus 1 e to the power minus beta x.
Okay.
So should we move forward? Any other questions?
No.
Okay.
Ma'am, I
Yeah.
don't have question as such, but then after you solve, I'm able to understand how it is solved. But when I'm able to start solving it, I'm stuck at some point or the other. Will that be resolved with practice, or is there anything else that I'll have to work on?
And that will resolve with practice. Sure.
Okay, thank you.
Yeah. But here, when we do solve it, just try to actually sit and solve and just put your answer whatever you get.
Okay, ma'am. Sure.
But try to solve here. Okay.
Sure, ma'am.
All right. We'll move to the next problem. So here the question says marks of 10th class students of a school follows the normal distribution with unknown mean mu and variance 36. So it is given to us that the marks follows the normal distribution with mean mu and variance 36. So mean is not known here. Mean is unknown to us, and from a group of 15 students, the marks have been taken, and these are the marks that have been recorded for those 15 students. Now you have to find the Bayesian estimate or the posterior mean of mu, assuming that this mu follows this normal 70-25 distribution. So you just have to, there's a direct formula also. You should, you can refer to your notebook and just try to get the answer. Still just 7 responses. Uh, Here you just had to use the formula, like you already had the formula with you. It is given in the lecture.
It's x bar n sigma naught squared, that formula only, right?
Yes, yes. So the formula is x bar n sigma naught square divided by n sigma naught square plus sigma square plus mu naught sigma square by again n sigma naught square plus sigma square. Alright, so let's not.
Ma'am, do we need to remember this formula,
No, you don't
or
need
you would be
to.
giving it in the exam?
This formula will be given to you.
Okay, ma'am.
Yeah.
Now that is easy.
Yeah, like it's a little difficult to remember, so
Yes, ma'am. Because how many formulas can we remember?
yeah, that is right. Okay, so it was quite straightforward. So you it was given to you that your random variable x follows the normal distribution with mean mu and variance 36, and now your mu follows the normal distribution with mean 70 and variance 25. So given this marks of 15 students, you have to find the posterior mean of this mean, right? Now what is the formula says? It says the posterior distribution of mu, uh, that will also be normal, and it will have a mean that is equal to x bar n sigma naught square by n sigma naught square plus sigma square plus mu naught sigma square by n sigma naught square plus sigma square. Okay, so x bar you can find using the sample that you have, right? The sample of 15 to 10 students that is given to you. um, this 10 students, right? uh, okay, 15 students. So from there you can find x bar, correct? So you find x bar, and you know that it is 15. And what is sigma naught square? What is sigma naught square in the
It's
question?
25, ma'am.
Yes, it's 25. So sigma naught square is the sigma naught and mu naught is this prior distribution. So prior distribution is normal with mean mu naught and variance sigma naught square. So here it's mu naught is 70 and sigma naught square is 25. Again, this sigma square will be what? Sigma square is 36. So just substitute the value, and you will get the final answer you're getting to be 60.87. Okay. Should I move to the next problem?
1 second, ma'am.
Okay.
It's done, ma'am.
Okay. I see people not putting their answers in the peer deck.
Actually, ma'am, in the lecture when sir explained this, I was not clear whether how this formula came up. I
You
noted it
didn't
down,
you,
although I noted it down, but
you
from
didn't
where
try
these sigma
to
naught squares and sigma squares
you
came.
didn't try to derive. So it's like the same. The process is same. So
The
like the
likelihood
prior is
into,
given, likelihood is given to
yeah.
you, and just proceed in the same way. You find the posterior. So once you find the posterior, you will see that it comes something in the form of normal distribution. Okay. So
Yes, ma'am.
once you see the distribution, the posterior distribution looks something like normal, then from there you will have to pick out what is your mean, and that is your posterior mean, right? Because once you get the posterior distribution, you just have to search what is your mu there. Once you find it, you are done.
Right, ma'am. No. Okay, I will try, ma'am.
Yeah, like try, like once you try, you will understand it properly. Like process is same, it just you have the formula given to you here in this case. Same way you can find the formula for everything, but for how many cases are they going to keep finding the formula? Like it's not good. Okay. All right. So the next problem we have is three out of the last 10 candidates wins a hunt come. Sorry, treasure hunt came. Previous record shows fraction of winners follows the beta A comma sex distribution. Okay, with an average of 40%. Now estimate the long term fraction of winners of the treasure hunt game. It's a little different than what you have seen before, but just let's try it out. So I'm
Ma'am,
sure, yeah, practice you have seen, you would have seen this problem.
ma'am, sir discussed in the last lecture of this week. Sir has discussed this problem two and problem two.
Okay,
I was not able to get that problem two.
I will come back.
It is, I think, I suppose it is just similar to it.
I will come back to that. Is there anyone who is not able to understand this problem?
I didn't understand it. I'm not able to solve.
Okay, so I'll just explain once. So it says 3 out of the last 10 candidates wins a treasure hunt game. Okay, so the information is already given to you first. So there are some 10 candidates, and out of those 10 candidates, 3 have won the treasure hunt game. Now, from the previous record, so previous record as in like it's a prior knowledge, okay? So prior knowledge for the fraction of winners. So let's say if the fraction of winners is p, so we'll say from the prior knowledge, it means their prior distribution for the fraction of winners. So let's say if we are saying the fraction of winners be p, then we'll say p. The prior distribution of this p is beta a comma 6. Okay. It is also given that uh, it follows this beta a comma 6 distribution with an average of 40%. All right. So what is given to you? P follows beta a comma 6 with average of 40%. Okay. So expectation is already given to you, and the distribution is already given to you. So once you know the expectation, you know the distribution, you can find this parameter here A.
A, yeah.
So once you know the parameter, you know the prior.
A comes to 4, I think.
A comes to 4. I will have to check. So you're saying A comes out with 4. So you know the prior distribution of this P. Now once you know the prior distribution, the likelihood is already given to you. So you just have to uh, find this posterior, right?
Just
Only
as a product.
posterior is,
Okay.
yeah,
Just as a product. Okay.
only posterior is left.
Okay.
Let's go to the solution part. So yeah, here also it's given to repeat. So let's say the long-term fraction of winners be denoted by P. So we are saying this fraction of winners be P. Now from the previous data, it follows a beta distribution with the parameter a comma 6. So we know one parameter, other parameter we have to find out, and how we'll do that, because the average is given and we know the distribution follows the beta distribution, so its expectation will be a divided by a plus b. In this case, b is your 6. So we'll use this information, and that this average is 40%. So we can equate both of this and we'll get a to be 4. Okay. So we know now what is our prior distribution. So prior distribution of p is beta 4 comma 6. So beta 4 comma 6 means what? So you know, if let's say if your random variable is x and your x follows beta a comma b, then its PDF is proportional to x to the power alpha minus 1, 1 minus x to the power beta minus 1, right? So now here we are saying this p follows the beta distribution with parameter 4 comma 6, then its distribution will follow like p to the power q 1 minus p to the power 5. Okay. Now, we already have the prior. We need the posterior density. So posterior is proportional to prior times the likelihood. Prior came out to be p to the power 3, 1 minus p to the power 5. And if you look at the question, it says 3 out of the 10 candidates. So you have 3 successes and 7 failure. Like it, you know, looking at the situation that it follows a Bernoulli distribution. So in that case, the likelihood will come out to be p to the power q 1 minus p to the power 7. Okay. So from there, you say our posterior density is p to the power 6, 1 minus p to the power 12. And again, it looks something like a beta distribution. So you can just find the posterior mean.
I think I'll agree with Krishna Priya. Once it's done, it makes all sense, but before that, it's difficult to solve.
like yeah, just maybe yeah, like first spend some time in reading the question properly. Yes, Shalendra, you have
Hello,
doubt?
ma'am. I'm sorry I joined
Yes.
late, but just want to know syllabus for the quiz, second quiz के लिए syllabus का.
Oh, it is completely out of the. Okay. So, this is syllabus will be from week 5 to 8, but you can expect like, but the topics that are covered in week 1 to 4, you should be
Yes,
like
yes, ma'am.
fluent with that.
Could it possible
Yeah.
to extend the deadline for the week 9 and 10 and 11?
Week 9 is already gone,
Yes,
right?
with 10 and 11 after 20th. Could it
After
possible?
20, week 10, it's not possible. Week 11, 12th, we'll see. Week till week 10, it is fixed.
Okay, then please extend after the 27th. 27th is the Python
Ma'am,
problem.
we have to do mock also. How do we
Yeah,
do assignments for Python, assignments for
yeah.
this
Week 10
statistics,
is
and
giving
two mocks?
problems. True. Week 10 is giving problems. I mean, we are not able
So
to even read.
Ma'am,
right now, week 10 is tomorrow, is it?
Yes, yes, ma'am. It
yes,
is day after tomorrow.
ma'am, or extend the date for the mock, ma'am. Do at least for the one of these.
Yeah, it's becoming very tight.
Mock deadline is Thursday
Yes, ma'am. The very next day, how
and
do we
Friday.
complete two mocks in a single day?
So today's Tuesday. You have Thursday deadline. So maybe Friday evening till evening we can keep the deadline for
Oh,
mock.
Yes,
okay,
yes,
ma'am.
yes.
Yes, ma'am. That would be
That
great
will be good.
if you
That
could
will work.
extend the mocks for
Yeah.
that day.
Okay. Yeah. Yeah. I will
I am a
inform.
working professional and I do not have whole day for studies.
Same thing with me. I have on the tour and I have attended the government meetings and also this session. Really, really, it is
Ma'am,
Same
very, very
here, ma'am.
extend the mocks
Yeah.
till Friday, ma'am.
Mock. So since we have mock session on Friday night, 8 to
Yes,
10,
ma'am. Yes,
so
ma'am.
we can keep it before the session. Yeah, that's all right.
okay. Thank you very much.
Okay. Yeah.
Ma'am, is week 12 new concepts or revision week, ma'am?
No, it's not revision week. It's hypothesis testing.
Oh,
It's continuation of 11th week, ma'am.
ma'am, last time also I didn't concentrated through week 5. Why? Because of quiz 1. And this time week 10 I am unable to do because of quiz 2. So most of the
Okay.
important concepts.
So we it's
Yeah.
yeah. Just try to like do few parts. I mean, if week 10 you're not able to do it properly,
Mm.
at least try to understand what is there. Just get the idea and just
Better
finish up the
after the
assignment.
quiz, if you conduct one more session for week 10, open session, ma'am, only for the concepts. So it would be
The
better.
sessions are already planned, yeah. But okay, we'll see if we can pull one more session there.
Even we asked for
Like
week
there are so many
5 also,
sessions.
ma'am, the other day before this
Yeah, week
quiz 2.
5 and 6 concepts.
Yeah,
Yes,
we
ma'am.
asked for the revision, ma'am, again.
It's
Week
tough.
5 and 6.
Another revision for five,
Madam,
six.
honestly, this may be for the namesake online,
Uh,
but for working professional like us, this is more than an offline mode only.
Yes, ma'am.
What is getting missed, and I'm so sorry
It's
that
too
it's not
hectic, ma'am. Too hectic.
yeah, the content is
Yes.
not
There's a
easy.
lot of content is there, and
And
we are
one
fully
more
no,
unable
problem
to
I
because
would
focus
like
on
to
the
that.
thing is,
discuss.
I've missed all mock physics and all that. Even the extra EPT also I missed just because I could not see and find them.
Okay. Yeah, there's so many things. Yeah, we agree. That's why
Yes,
even the
ma'am.
sessions.
This term is the hectic with even two subjects. Even I have taken
And not
statistics
for
and
just
Python
one
along with.
subject. Other
It's
And
subjects
no,
have
no.
their own
It's
deadlines and their
there
own.
are so many
if
assignments in
you
Python, ma'am. Practice
if you
assignments,
if you
tests.
The
if you
same is the
hear
scene with mathematics also. I have
if
taken
you
math and
hear
stat.
stories from diploma, the students who are currently in diploma, they will say mock is like foundation is nothing compared to
Oh,
diploma. So like since you are going to higher level courses, it's going to be more rigid. So you have to be prepared.
it means we have to take only one subject, ma'am. Not more than
Ma'am,
Depending
it
on
would
how
take
you
10
can
years to complete then.
that. Seriously, when we are working.
Yeah.
Bec-
Yeah.
I thought that last time four I have taken, it became so hectic. That's why this time I have taken only two. The two is
Okay.
equal to four, ma'am, more than equal to.
Yeah, yeah. Like from the
Math and
starting, we
stat.
have been telling students like
Yes, ma'am.
it's not very easy. Even Python, maths too, starts to
So, madam, for
all are
the
difficult.
senior, not citizens but students,
Mm.
do we have any, guide which we used to get in our times, with which we can prepare 15th, 5th, and week 5 to week 10 or 8, whatever it is?
Uh, okay,
Going through
okay.
the revisions will take about a week or more, and hardly we have 3 days to do that
So
preparation.
you want, but the thing is, if even the students will have exam, no, this week.
Yeah.
Yeah. So yeah, let's see. Because if like we have stays and but the thing is at this week it's difficult to conduct one more session for week 10 or week 5 6 you're saying.
Yeah.
With students it's a little difficult this week because they are also in diploma and they will also have to write exam. So we have one session on Friday, I think after this. Yeah.
Friday already we have session for mock, no ma'am.
We already have one session for mock.
Yes, ma'am. So it would be better if it is tomorrow or day after tomorrow.
Do we have any recorded version of any such thing wherein we can go?
Of week 5 6, it is already there on the portal recorded thing.
No, they
Yes,
are the
ma'am. But
individual videos,
still,
madam. If you had run them through,
yeah.
then it would not be able to finish in 1 week, full 1 week, somebody has to dedicate.
Mm,
Especially conditional density and all.
okay. Okay. Let me talk to other people and let's
Sure,
see.
sure. Thank you, ma'am.
Well,
Thank you.
basically, for people who are working professionals, this can come handy with respect to the time available. And if they go through that, at least they'll have some passing mark or some respectable marks to pass clear this exam. To be very honest.
Okay. Okay. We'll talk on that
Ma'am, excuse me, ma'am. I have one doubt here.
in the question.
No, ma'am.
Okay.
The just which is there on the screen. The it
Hmm.
is P of x1 equal to that means likelihood into the
Trial.
density. Yeah, prior.
Yeah.
How come we got that p cube into 1 minus p power 7? No?
Oh, well, okay. Look at the question here.
3 out of last 10 candidates.
Yes, three out of the last 10
Yeah, yes,
candidates
ma'am.
went a treasure hunt came.
Yes, ma'am.
So it comes from there. So, this is kind of a Bernoulli case, Bernoulli distribution.
Mm.
Like you,
Hello.
Ma'am, you are not audible.
Yes, ma'am. Not audible.
Not to anyone?
Now you
Now
are
you are
audible.
audible, ma'am. Now you are audible.
Oh, okay, okay. I think my earphone. So what I was saying is, the posterior. Now you understood how we got PQ 1 minus P to the power 7, right?
It's binomial, right, ma'am?
Not binomial. It's coming from this Bernoulli.
Yes, I mean Bernoulli. Yeah, yeah.
Yeah.
Yes, ma'am.
Okay.
Thank you.
Yeah. So one more problem we have. It's kind of same what we have seen before. So the question says the outcomes on tossing a coin 15 times. So we have tossed the coin 15 times, and these are the observation you have found. And we have taken the probability of heads to be P. And using the previous record, head appears on an average, like you have used the same coin, and from the previous record, we are saying that head appears on an average 70% of the time. Now find the posterior mean of P using the beta 7 comma beta prior. So it's the same kind what we have seen in question number 3. So just take your time and try to understand the problem. Write down everything properly, and then just solve it.
Can we discuss the algorithm of this question or not?
Yes, okay.
Ah, what I suppose is that if we can get P, then we would find the likelihood
Hmm.
of this Bernoulli, right?
Hmm.
And the density would be likelihood into prior. From there, it would turn into some distribution.
Hmm. Yeah. It's the same. The question is exactly the same what you saw in the third problem. What you solve in the third problem, right? It's exactly the same. The idea is exactly the same. Just try it out.
Ma'am, how many questions left, ma'am?
This is the last problem.
Okay. Okay.
Okay. Are you able to solve?
The posterior is also beta distribution, right?
Yeah. What is the posterior mean you got?
0.6.
0.6. Okay. Alright, so here also we had to find the posterior mean of P using the beta 7 comma beta prior. So we have the parameter here to be P, and we don't know what's value, and it follows some distribution, and from the prior knowledge we know its prior distribution is beta 7 comma beta. Okay. And its average value, like its expectation, is 0.70, right? So again we can use this information to find this beta, and we also have this outcomes of the tossing a coin. So using that, we will find the posterior. So we have the p, let p know the probability of heads, and given the prior of p to be beta 7p, average 0.7. Again we find first the beta value. So once we find the beta value, we get our prior distribution for p. After that we need to find the posterior. So for posterior we need likelihood, and for likelihood, since we are interested in number of heads, we can just simply count how many heads are there. So we have 1, 2, 3, 4, 5, 6, 7, 8. So out of 15, you have 8 heads and 7 tails, right? So your likelihood will be p to the power 8, 1 minus p to the power 7. And again, once you solve it, you see that your posterior density comes out to be a beta distribution with the parameter alpha to be 15 and beta to be 10. And once you have the posterior density, you can find your posterior mean. That is 0.6. So the same process. Any doubt in understanding this problem?
Ma'am, I don't have a doubt in this problem. I just want to understand if you will make this deck as student accessible as sir used to do for the past 2 weeks, will that be possible?
Sorry.
Okay, last 2 weeks when this kind of session happened,
Mhm.
like solve with a session, sir, after the session, sir made this slide student accessible, which means like we can scroll to next slide. So will that also
Okay,
happen?
student based.
Yeah.
Uh, yeah, that will happen. When
Okay,
after
ma'am.
the session, we'll make it student based and upload.
Okay, sure, ma'am. Thank you.
Actually, what he would do
Please
is
upload today, ma'am.
he would make it student based right now, so that the window that we have opened it in remains student based. Student.
Okay. Okay.
Yeah.
Okay. I will also do the same thing. So no doubt in this problem, right? Okay. So I'll just close this window. Oh.
चलो ये तो हो गया, एक तो हो ही जाएगा कम से कम.
Can you mute yourself? Just yeah. Okay, so I made it student based. You can check.
Thank you.
Yeah. Yeah, Kaushik. Go on.
Hello, ma'am. I have a question, not from today's session, but generally from about maximum likelihood. Can I ask
Maximum
that?
likelihood. Yeah, okay.
Yeah, so in the maximum likelihood algorithm, sir said that basically when we have to maximize the likelihood, we always equate it to zero, right? And that means we are assuming that the likelihood function will always have a global maximum, right? And it will not have any local minima or maxima in that function. And then we are solving for the parameter, if I
Then
understand
you're
correctly.
solving for a parameter. Yeah.
But but is it always true that the likelihood function, which is a product of the PMF or the PDF, is it always true that the likelihood function will have only a global maximum and not any local minima or maxima? Because if I equate it to zero, it could also be a minima if the function, if the product function, if the likelihood function had
Mm.
a minima, right? Or even a
Local max.
local
Yeah, yeah.
maximum.
It can happen.
So, but when I equate it in all the problems, basically we equate it to zero and we find the estimate as the argument. That means we are assuming that it will always have a global maximum, right? But that may not be the case.
Yeah, I think somebody else also had asked this. Okay, so
So in our case, do we by default always just assume a global maximum, or that's my question, or or should we not check with the second derivative whether it's a local maxima or minima? Do we have to check that, or we can just by default equate it to zero and assume that it's a global maximum? That's what I wanted to know.
by default, like you can always do equate it to zero and get the value and say maxima. You don't have to like look for minima or something.
So then we are assuming that there is no minima in the function, right? I mean, the
There is
problems will be such that there will be not
in
minima.
the yeah.
In the second derivative, it will be negative. So it
Yeah.
will
So
be,
are we supposed to
That is
check
one
that?
way. No, you're not supposed to check that.
if you check it, it will be negative. So it means that it's a maximum.
Yeah, I mean, that's what I'm asking. So either we assume that there is only a global maximum, and in that case, we don't check the second derivative, and we just equate it
Hmm.
to zero. Or other thing
No,
is
you
for
just
the
there is no like you equate it to zero and that will give you maximum.
okay. So then we are assuming that the likelihood function will always have a global maximum, at least in this
Vikan sir
particular
said
algorithm.
that in this particular course, whatever examples we are having, they will be all be having global maxima only. In the
Okay.
there may be conditions where there will be minimum would be there, but in this course, every example will be such that it will be a maximum. I asked this question in last time also. I got this answer.
Oh, okay, okay. Thank you. Yeah, and one more question. In the t
Mhm.
distribution that when we use a t distribution for confidence
Okay.
intervals, uh,
Mhm.
uh, normality condition has to be satisfied, right? It has to be the samples have to follow a normal distribution, and only then we can use a t
Yes.
distribution, isn't it?
Yeah. Yeah. Right.
Otherwise, we cannot. It's not applicable to find. I mean, find a confidence interval using a t distribution, if I understand correctly.
Using t distribution.
So it has to be normal. The samples have to be normally distributed, and the
Right.
variance is unknown. And then we
Radius should
estimate,
be unknown.
and
Yes.
then
Yes.
and then we estimate it using a sample variance, and only then we can use a t-distribution for
Then you.
confidence interval.
Yes. Yes.
Okay, thank you. That's all.
Yeah. Any other doubt? Okay. So if there is nothing, we can close the session. And for the mock extension, like we'll talk and just do it. And also regarding the week 5 6 session, we will see what date can we adjust. Okay.
Okay, ma'am.
Yeah.
Thank you for today, ma'am. I was not very clear about finding the posterior mean. I think after today's session, I got a good idea. Thank you for this.
Okay. Yeah. Thanks.
Thank you.
Thank you.
Bye bye.
That's good. Yeah. Thanks. Bye.
Thank you, ma'am.
Thank you,
Thank
ma'am.
you. Thank you, everyone. Good
Thanks,
night.
all.
Okay. Bye-bye.
Thank you, ma'am.
Bye, ma'am.
Thank you all. Thank you.
Good night, ma'am.
Good night.